All right, hi guys, welcome back. So we are going to start 7.2. 7.2 is called molar mass, and so we're going to talk about moles and mass. And the learning goal is, given the chemical formula of a substance, calculate its molar mass. So what is molar mass? Well, molar mass is just a quantity in grams that equals the atomic mass of that element, and it's the mass of 1 mole. So if I have 1 mole of something, what's the mass of it? So it would be the mass of 6.022 times 10 to the 23rd atoms of an element. Or if we're talking about a compound, it could be 6.022 times 10 to the 23rd molecules or formula units of that element, of that compound. The molar mass of Miss Lewinsky would be the mass of 6.022 times 10 to the 23rd me's. So it would be a very big number. But remember, when we're talking about atoms and compounds, those are very small masses. So the mass of them, if you've got a bunch of them, it doesn't add up to a whole bunch of mass. It makes it more realistic. So if we're talking about carbon, remember, is how we design the mole. How much is a mole? So the mass of carbon is 12.01 grams. That's 1 mole of carbon. Okay, so that's its molar mass. And you can get those, if you're talking about an element, you get them right off your periodic table as that mass number. So 1.07.9, that's the molar mass of silver. That's how much silver would be in grams if you had 6.022 times 10 to the 23rd of it. Sulfur has a molar mass of 32.07, meaning if I have a mole of sulfur atoms, the mass of it's going to be 32.07 grams. Now, if we're talking about compounds, so not straight off the periodic table, if you're getting it from the periodic table, you just look at the number of the mass, the atomic mass, and that tells you in grams how much would 1 mole weigh. But if we're going to talk about compounds, it's going to be, you have to add it up. So to determine the molar mass of a compound, you want to multiply the molar mass of each element by its subscripts, and then we add the results and round to 0.01 grams. So take NH3, for example. You would have to find the mass of 1 nitrogen, or 1 mole of nitrogen atoms, plus the mass of 3 hydrogen moles and add them together. So 1 mole of NH3, well, 1 mole of nitrogen is 14.01 grams. So that's pretty straightforward. We just got that from the periodic table. The mass of hydrogen is 1.01 grams. So we do 3 times that and add it all together, and you get 17.04 grams of NH3. All right, so let's try one of these. Calculate the molar mass of lithium carbonate, so Li2CO3. So we're not necessarily going to use cups for these because there is no plan. But I'm going to show you how to do this one. Okay, so Li2CO3 means we have 2 lithiums, right? So lithium has a molar mass, I look at my periodic table, of 6.941. Now that means that if I have a mole of lithium atoms, that would weigh 6.941 grams. Now it says based here that I've got 2 lithiums, so I need to add 6.941 grams. So I've got 2 of those, right? Because I've got 2 lithiums, it's lithium 2. So then I have to also add in carbon. So I'm going to add in the mass of carbon. We know that carbon's 12.01. That means that 1 mole of carbon atoms is 12.01 grams. And then 3 oxygen. So oxygen has a molar mass of 15.9994. We've got 3 oxygens, so I'm going to write that on there 2 more times. 15.9994 and 15.9994. Okay, so to calculate the molar mass of lithium carbonate, I need 2 lithiums, 1 carbon, and 3 oxygen molar masses added together. So I'll pull up my calculator. And so I'll do 6.941 plus 6.941 plus 12.01 plus 15.9994 plus 15.9994 plus 15.9994. So we get a total molar mass of 73, and we round to the hundredths of a gram, so 73.89 grams. That would be the molar mass of lithium carbonate. Okay, so the next couple slides just walk through that with you again. If you want to take a look at those, you can go ahead. Here are some examples of 1 mole quantity. So this is 1 mole of sulfur, 1 mole of iron, meaning that there are 6.022 times 10 to the 23rd sulfur atoms in here. Same thing of iron. This is sodium chloride, salt, so that would be 6.022 times 10 to the 23rd formula units of sodium chloride. Potassium dichromate, so that means there's 6.022 times 10 to the 23rd molecules there. Formula units, because that's ionic. And then sucrose, which is a molecule. That means that that meant a mole of sugar molecules there. So you can see, depending on what we have, a mole is a different amount. Same kind of thing, molar mass of selected elements and compounds. Let's try another one. Calculate the molar mass of potassium chloride. All right, this one's going to be a little more straightforward. We look up the molar mass for potassium, which is just off the periodic table, and it says 39.0983 grams. Okay, so if we have a mole of potassium atoms, it would weigh 39.0983 grams. We only need one of those because we only have one potassium. And then we can look at chlorine, which has a mass of 35.4527 grams. That's its molar mass. And so we just add those together because, again, we only have one chlorine. So I would do 39.0983 plus 35.4527. You get 74.551, round to the nearest hundredth, so 74.55 grams would be the molar mass of potassium chloride. Again, these just step you through the steps for that. All right, that's all we have for molar mass, so go ahead and leave room for a summary, and we will do some problems. Toodles.